This is problem 119 from chapter 16. In this problem, the wheel rolls without slipping such that at the instant shown it has an angular velocity of omega and angular acceleration of alpha, and the direction is shown in the diagram here. Determine the velocity and acceleration of point B on the rod at this instant. So we have point B, which is a distance of 2a away from point A, and the radius of the wheel here is point A. So I feel like we've spent a lot of time in this section, and for this problem, I'm just going to walk you through the solution. So we are looking for the velocity and the acceleration of point B. So this actually includes material from a previous section to find the velocity, and then material from this section to find the acceleration. Okay, so we're going to start off by finding the velocity. And I have, from my equation sheet, equation 1616, which I want to use to find the velocity of point B. But in order to do that, I need to find the velocity of point A. So to find the velocity of point A, I can actually use the same equation here, but make the B an A, and make A the instantaneous center of zero velocity. Because the velocity of the instantaneous center of zero velocity is 0, that gives me this equation here where r is the vector that goes to point A from the instantaneous center of zero velocity. The instantaneous center of zero velocity for a wheel that rolls without slipping is the point which is touching the ground at this instant. So we want to find the velocity of point A. The angular velocity they told us is omega. That's going in the k-hat direction. So there's our angular velocity vector. And this vector is going to point A from the instantaneous center. So that is from here to here. Because the radius is A, the distance that we go in the x direction, that's from here to here, that's the radius. So that's negative a I hat. And in the j hat direction, that's going from here to here, that distance is also the radius, that's positive a j hat. So we have our position vector here, and so we put this in here and this in here. That gets us this equation here. We do the cross product. K hat crossed with I hat is j hat, so that's minus a times omega there. K hat crossed with j hat gives me negative I hat, so it's omega times a. Now it's negative from the cross product. Okay, so now here we have the velocity of A. Now I'm going to use equation 1616 with the velocity of A that I just found. And when I do this, because I'm looking at points A and B, this angular velocity is the angular velocity of AB. So using equation 1616, I have point B, and this point is staying on the surface here, so that velocity, well, it must either be in the positive I hat direction or the negative I hat direction, but I will let the sign tell me what direction it's going in. I just found the velocity of point A up here, and the angular velocity of AB I do not know, but I do know it must either be going in the positive k-hat direction or the negative k-hat direction. So again, I'll let the sign tell me whether it's going in the positive or negative k-hat direction. And this vector r goes to point B from point A, so that points this way. And so this distance is 2a. Then the distance from here to here is the same as the radius, so that's a. Now, this is a reference triangle, which you may remember from a math class. So this is 1 and this is 2. Then this side must be the square root of 3. So this is the square root of 3 times a. So the distance that we go in the negative I hat direction is 3a, and in the negative j hat direction is a. So that's this vector. Okay, so now we're going to do the cross product for this equation here. So we take our vector for the angular velocity, put it in here, cross it with our position vector. K hat crossed with I hat gives me j hat, so it's this times this in the j hat direction, and it's negative because of the negative sign here. K hat crossed with j hat gives me negative I hat, but I had a negative sign here, so this is this times this, and it's positive in the I hat direction. Okay, now I take, this was equation 1616, and I plug in all the stuff that I found here into equation 1616. VB just has an x component, and VA is what I had here, so this is VA minus my cross product, which I had here, so minus this. And then I look at the j hat components. There's no j hat on this side, so I have a j hat component here and a j hat component here, and I can use this to solve for angular velocity AB. So if I bring this over to the other side, I have omega times A is equal to negative square root 3 times A times omega AB, cross out the A's, and you get omega AB is equal to negative omega over the square root of 3. And so we said omega A, the vector for the angular velocity is omega AB times k hat, which means this is going in the negative k hat direction. Now I can look at the I hat components, which I have here. So VBX is equal to minus omega times A plus A times omega AB, and then we take this and put it in for omega AB. And then this is, if I pull out an A times omega, that leaves me with a 1 from this term and a 1 over square root of 3 from this term. And 1 plus 1 over the square root of 3 is 1.577. So you could write that as this also. If you keep it in exact form, your velocity for B just had an x component. So here's your velocity for B. Okay, so that was the first thing that they asked us to find. Now we also get to find the acceleration of point B. So we're going to use the equation that we've been using in this section. So this is equation 1618. And so I have that here, and then I'm going to look at what I know in this equation. So point B is staying on the surface, so that acceleration must just have an x component. The angular acceleration of AB, it must either be in the positive k hat direction or the negative k hat direction. I also need acceleration A. I don't know this, and I don't know this, so that's already two unknowns, so I'm going to have to find the acceleration of A. To do that, I can use equation 1618, which is what I have here, again, but with two different points. So this is kind of, if you compare it to what I did when I found the velocity, I have my equation here for relative velocity, and I was able to find VA by using the instantaneous center of zero velocity. But we don't have an equation similar to this for the acceleration, so instead we're just going to use equation 1618 again. But I do know something which is going to be helpful, and this was rolling without slipping. They mentioned this on the bottom of page 374. For rolling without slipping, the acceleration of the center of the object is equal to the angular acceleration times r. So I want to use point O, which is the center of my wheel here. So I'm going to use equation 1618 with point A and with point O. That gives me this here. And I need to know the acceleration of point O. Well, for rolling without slipping, that's angular acceleration times the radius A. And because the wheel is accelerating this way, like this, that acceleration must be pointed this way. Or you can say if angular velocity and angular acceleration are in the same direction, the wheel is speeding up. And so if it's rotating like this, then the velocity is this way. So if it's speeding up, the acceleration is this way also. So that gets us this for the acceleration of O. I have alpha, my angular acceleration crossed with the position of A with respect to O. That's going to point A from point O. So that's going this way. The magnitude is A. So that's negative A I hat minus angular speed squared times the same vector here, position of A with respect to O, so that's this. Okay, so we take our acceleration for point O, put it in here for that. Then we have the cross product here. We're saying from our picture here, the alpha is like this, that's in the k hat direction, so angular acceleration crossed with position minus angular speed squared times position. When we do the cross product here, we have k hat crossed with I hat, giving us j hat, so that's minus alpha times A in the j hat direction, and then this is negative and this is negative, so that's plus omega squared times A in the I hat direction. Now let's combine the I hat terms, so this is omega squared minus alpha times A in the I hat direction minus alpha times A in the j hat direction. So that's the acceleration of point A. Okay, so now that we know this, we can use what we had here along with the acceleration of A, go back to equation 1618 and start plugging things in. So AB has a component just in the x direction, so we got that there. Then this whole thing here is what I found up here for the acceleration of A, plus cross product, so that's acceleration AB, which it's either going in the positive k hat direction or the negative k hat direction. So this crossed with my position. Oh, my position vector, that's what I found here. So this is the same vector as what I had before when I did the velocity. Minus angular speed for AB, which I found back here in terms of omega. So angular velocity of AB is equal to negative this angular velocity divided by the square root of 3. So that goes in here, that's squared, and then my position vector here is the same thing that I had before. Okay, so we're going to keep this the same. We're going to, this here is the cross product from up here, so k hat crossed with I hat gives me j hat. This is alpha AB, then I have the minus square root of 3 times A, so that's this crossed with this, giving me this. Then k hat crossed with j hat gives me negative I hat, but this was negative, so this becomes positive. This is alpha AB times A, so that's giving me this here. Then for this here, which came from what I had up here, we're just going to distribute the negative sign and take this, multiply it by that. So this is squared, so it doesn't really matter that this is negative because that's being squared. So negative times negative gives me something positive. Omega squared times the square root of 3 times A divided by the square root of 3 squared, so that gives me this here. Then omega squared times A divided by the square root of 3 squared, that's 3. And this is negative times negative, so this becomes positive. Okay, so this is our equation here, now simplified. Then I'm going to look at the j hat terms and the I hat terms. Maybe I should say A, B, X, I hat here. Okay, so now we're looking at what we have here, and we're going to do the j hat terms first. So no j hat term on this side, so I have a j hat term here, and a j hat term here, and a j hat term here. So let's take this one and bring it over to the other side. So I have minus alpha A plus omega squared A over 3 is equal to, this on the other side would be positive square root of 3 times A times alpha AB. Then the A's cancel out, and you can solve for alpha AB. So it's this plus this, which we have here, divided by the square root of 3. Okay, and because we said up here it was going in the k hat direction, we can write this as a vector. Now, looking at the I hat terms, we have ABX, we have our omega squared minus alpha A, plus, here we have A times angular acceleration of AB, so that's what we found here. So take this, put it in here, that gives us this, plus omega squared A times 3. Now, I wasn't supposed to cross those out there, so ignore that. And we're going to combine things together, and that will give us, this is the x component, but remember, it only has an x component. So this is the acceleration of b, which is what we were asked to find. We have omega squared times a, that's here. Okay, now we have an omega squared times a here over the square root of 3, so that gives us the 1 over the square root of 3 here. This is omega squared times a divided by 3 divided by the square root of 3, so that gives us this here. And this term in parentheses here is 1.77, so you could write this as omega squared times a times 1.77. Then we have the minus alpha times a plus a times negative alpha divided by the square root of 3. So this is giving us a 1, and this is giving us a, oh, this was negative. Okay, so we'll put the negative sign out here, and this is also negative, so if we put the negative sign out here, this is 1 over the square root of 3, which is 1.58, and this is our answer for the acceleration. Okay, so this is what we have for finding the acceleration, and this is what we had for finding the velocity, and that concludes problem 119.